Okay, so here we have um, a spotlight on the ground shines on a wall 12 meters away. Okay, so you want to first start with drawing this and see what's happening here. So basically, you have this wall and then you have this spotlight. So the spotlight is like this right here, and it's shining onto this wall, something like that. Okay, and it's making this, shine over here. A man 2 meters tall walks from the spotlight. So he's basically here, right? And he's 2 meters tall. Okay, and that this distance is 12 meters. Okay, and if a man walks from the spotlight toward the building, and his rate of travel as he's walking, how fast is the length of his shadow? So we got to imagine what his shadow is going to look like. So here the light hits the top of his head, and he's going to be casting a shadow that I'm going to draw in the same color right here. So here's his shadow, right? Now as he walks, right, this is going to decrease. This angle here is going to decrease, which is going to decrease the length of his shadow as he moves along here. Now this one's tricky. You got to think about what quantities are really related here. So now I want to come up with first a formula relating the length of his shadow, okay, on the building with his height, which is 2 meters, and I suppose how far away he is from the building, right? Or how far away he is from the spotlight, which is the same thing. So I'm going to do it with calling each one of these quantities. And again, I don't know. I just started this one. I don't know. I'm going to call this length X. I'm going to call this length Y. And I'm going to try and come up with a relationship between these quantities. And I already see the relationship. So these two triangles are similar triangles. So because of that, I can write an equation relating X and Y. So let's see. So this, right, this is going to be one triangle. And it's, 2 over X, let's say, is going to be equal to the relationship with the big triangle is going to be Y over 12. Okay, and now now that I have that, I have that then I could say that 24 over X is equal to Y. And now I have a relationship relating these two quantities. And with that, I think I'm good, because now I also have, right, that he's walking toward the building at this rate. So X is increasing. dx dt is 1.6 meters per second. And I want to solve for dy dt. So it should be good, because now, when he's 4 meters from the building. So when he's 4 meters from the building, when this length is 4, right, this x length is going to be 8. So I'm going to have an x length as 8. And I'm looking for, and if the x length is 8, we got to know what y is right away. So if he's here, right, we should solve for the length of his shadow. But we have a relationship relating these things. So 24 by 8 is 3, so I have y as 3. And then now my last step is to just differentiate the relationship that I solved for. So differentiating the relationship is going to be, this is 24. Remember, I'm differentiating with respect to t. This is 24x to the negative 1 is equal to y. The derivative is going to be negative 24x to the negative 2 times dx dt is equal to dy dt. And I know that I'm going to get negative 24 over x squared. X is 64. X is 8. So it's going to be over 64 dx dt. I know dx dt. dx dt is 1.6. So it's negative 24. 64 times 1.6 is dy dt. And that's the rate at whatever his shadow is going to be decreasing at. I could do the math here. I don't know, 12, 32, 6, 16, 4, 8, 1/4 times 16 over 10 is 8 over 5. This is 2/5, negative 2/5 is dy dt. Maybe I did that arithmetic wrong, but it would just be the arithmetic. Let's just make sure. 16 over 10 is 8. Is 8/5, and then the 4 cancels with the 2, so it's 2/5. Yeah, and this is negative 2/5 meters per second is how fast his shadow is shrinking as he moves along at this rate. I mean, again, the trick is though in these problems is always trying to find the relationship between the relevant quantities. In this case, it was this, which wasn't so bad. I thought it was going to be a little bit harder, but I mean, we got to see that they're similar triangles, and we got to really be able to envision what's occurring here with the light as he moves, right? Because as he moves, this light is going to shine like that, and then his shadow is going to be this long. And you got to remember that it's a similar triangle to the original. Is this true? 12. This is 12, yes. Oh, and then that's 2. Right. Yeah. Okay, they are. Good, yeah. This triangle is similar with that one. Yeah, making sure I didn't do anything wrong. Okay, we're good.